Good morning to all. Myself Dr. P. Ramesh, Assistant Professor, Department of Mathematics, Ratnam College of Arts and Science. Today we are going to see the set theory topic. Okay. First, we should know about the set. What is set? A set is a well-defined object. Otherwise, you can call it as a collection of distinct objects. Okay. So there are a lot of examples are available. Collection of all things, collection of all chairs in this room, collection of all fans in this room. Likewise, you can generate many examples. Okay. So George Cantor, who is a founder of the set theory. Okay. And sets are conventionally notated by the capital letters. So these guys are the George Cantor. Next, examples of sets. Collection of all faculties in the Ratnam College of Arts and Science. So you can collect the faculty members, you can form a sets. You can notate capital A, which is curly bracket, and Ramesh, Kavita, Kathiresan, dot, etc. all the faculty members, you can close the set bracket. So this is called an set. Okay. So next example, collection of all books in this Ratnam library. So everything having a certain relations. Okay. Next, collection of all tables in the classroom. In this classroom there are 12 tables. Okay. So you can collect this table number 1, 2, 3, etc. number 12. So this forms a set. Okay. Now we are going to see some special sets. Okay, special sets. Here P is a prime number. It denotes a prime number. Before that, you should know about the prime number. What is prime number? A prime number which must divisible by only one and itself is called a prime number. All other numbers are called an composite numbers. You can collect, choose number 2, it's divided by 1 and 2, so it is a prime number. Take 3, 1, it is divisible by 1 and 3. No other elements or numbers divisible by 3. Okay, so 3 are prime number. Similarly, you can collect the prime numbers 2, 3, 5, 7, etc. These are all the prime numbers. These prime numbers forms a set. Okay. Next, n. This n represents a natural numbers. What do you mean by natural numbers? 1, 2, 3, etc. So this is called an natural numbers. Next one, integers. Integers set of all integers forms a set. So this is an on your right side 0, 1, 2, etc. up to goes to infinity. In a similar way, your left side 0, -1, -2, etc. Okay. So this is a set of all integers which forms a set. Next one, Q, rational numbers. So I think you are very familiar with the rational numbers. What do you mean by rational numbers? It must in the form of A by B, and here A and B must belongs to the integers. Also you should note that your B must be not equal to 0. If it is 0, then it is an infinite. Okay, so it does not belongs to Q. So this thing you have to remember. Okay, so for example, you can take A and B. A is equal to 1 and B is equal to 2. Okay, so you will get what? 1 by 2. So it is an one rational number. Another one, you take A is equal to 2 and B is equal to 3. So you will get 2 by 3. This is an rational number. So in a similar way, you can collect many rational numbers. This rational numbers forms a set. Okay, fine. Next, R. What is R? Set of all real numbers. This script R is a special notation for special notation for real numbers. Okay, you can collect the your real numbers is nothing but union of rational and irrational numbers, and 1, 2, root 2, everything is real numbers. Okay, fine. Next one, complex numbers. In our complex number, is the form is what? A plus IB or BA. Okay, and A comma B belongs to R. For example, you take A is equal to 1 and B is equal to 2. Your 1 plus 2I belongs to C. Okay, that is complex number. Okay, collection of all complex numbers forms a set. Okay, next example. This is what we have seen in the previous slide. Set of all prime numbers, and A is equal to 1, 3, 9, 12. There is a relation, everything is a number. And third set, that is what? B equal to red, orange, yellow, green and blue. There is a relation. What is that? Collection of all colors. Okay, so there is a relation, so it forms a set. It is a well defined object also. Okay, next one, take an example C. I mean C set. It is a very interesting one. Okay, C is equal to what? 2021 and Ratnam and I. Is there any relation between these three elements? There is no relation between these each elements. Okay, so it never forms a set. Before that we have seen how to make a set. This is an example of not a set. Okay, in a similar way you can create some other examples. Think yourself. Okay, next one, types of sets. There are many types of sets are available. First we are going to see the finite set. What is finite set? A set which contains only finite number of elements is called an finite set. For example, you just look at your A, 1, 2, 3, etc. 2000 at the end is what? 2021. So it is ended. So it is an finite set. And this A is what? Tamil, English, Telugu, Malayalam. So it is ended. So it is a what? It is a finite number of elements. In a similar way you can create some other examples. Okay, next one, infinite set. A set which contains infinite number of elements is called an infinite set. Okay, take a set, this set A is equal to what? 1, 2, 3, 4, etc. dot dot dot. What it means? It goes towards up to infinity. So it is which does not have an finite number of elements. So it is an infinite number of elements. So this set A is an infinite set. Okay. Next one, you take set B. It is what? Set of all rational numbers. Previously we have defined what is rational numbers. You just write 1 by 2, 1 by 3, dot dot dot, etc. So it contains infinite number of elements. So this set of all rational numbers forms a set as well as infinite set. Okay, because it contains infinite number of elements. Next, C. So think about your C. Okay, so I just move on the next slide. Singleton set. A set which contains only one element is called a singleton element. Okay, singleton set. Take A is equal to 5. This set contains only one element. Okay, so it is an singleton set. Okay. Take set B. Your set B is equal to 0. 0 is also one of the element, so it is also an singleton element. Some people are thinking like it is a 0, so it is no value, so it may be empty set. Think like that. So it not but originally what? It is a singleton set. Okay, consider C. Your C is what? Ratnam College of Arts and Science. in the world there is only one college, Ratnam College of Arts and Science, in the whole entire world. So it is a singleton set. Take D set. D is equal to what? 2, 3. This set having more than one element, that is which this set contains 2 elements. So it is not a singleton set, because singleton set contains only one elements. Okay. Next one, null set. Null set. Null set or empty set. A set which contains there is no element is called a null set. Okay. So null set denoted by empty, notated by this notation or this curly bracket. For example, set of all students in this classroom whose name started with the first 2 letters Q and Z. Is it possible? Maybe sometimes possible, but in my classroom it is not possible. So my A is equal to empty set. Okay. So this is one example. And set B, set of all integers whose square is 5. Take an integer, for example, take 1. 1 square is what? 1. 2 square is what? 4. 3 square is what? 9. So which is impossible to make 5 by using integers. So it is, there is no element in the set B. Okay. So it is this B set is an null set. Okay. Equal set. Equal set. What is equal set? If 2 sets are equal, then we can say that equal set. That means every element of A which occurs in B, also every element of B also occur in A. For example, just look at your A. Your A set is what? 2, 3, 5, 7. Your B set is what? 3, 7, 5, 2. Elements may be interchanged, but every element of A which is occur in B, also as well as every element of B occur in A. So this sets is called an equal sets. Okay. So thank you to all. I hope this session will be understandable. Okay. Thank you.